For part 2, let's kick off with a basic starter patch. We want the patcher to start with the jit.world toggled on. For convenience, we can specify the jit.mo functions by replacing the func with the function name. Let's make a jit.mo.line and a jit.mo.sin for sign function. Next, make a Gmo join with 3 planes and a dimension of 100. Connect the mo.line into the left inlet and the mo.sin into the middle inlet. Next, make a jit.gl.mesh with an @draw_mode attribute, and we want the mode to be line_strip. Join the outlet of mo.join to the inlet of gl.mesh. Let's add 3 attributes to the jitmo line. Let's make these attributes frequency, scale, and speed. Duplicate these 3 attributes and join the same attributes to the jitmo sin. Set the frequency to 3, the scale to 0.7, and the speed to 0.5 for both functions. Next, let's check out one of the abstractions that comes with the Gmo package. It's called Gmo Grid. Make a Gmo Grid and give it an argument of 30. Join mo.grid between the mo.join and the GL mesh. What this does is it takes our matrix coming out of the Gmo join and repeats it 30 times. By adding a floating point number object to the right inlet of the mo.grid, we can change the Y scaling as we please. Now we can put in a jitmo field between the mo grid and the GL mesh. Add a force attribute and change it to 0.3. You can really see the force field in effect here. It looks pretty neat as the sine wave tries to move across the force field. Now, like part 1, let's duplicate the second jitmo func section. Copy and paste and reconnect it to the middle inlet of mo.join. Now you can see when we start to join things together, we can get into some really wild manipulation of our imagery. Another thing we can do is run it through another object called a Gmo texture. Make a Gmo texture. It takes the output from our mo.field or mo.grid, and then we can put that onto a texture. We can actually just go ahead and connect that texture to our jit.world. You can now see the data generated by our jit.mo texture interpreted as RGB values. These can be mapped onto a 3D object or used as a background. Let's make a jit.gl.grid shape and apply the same texture to it as well. Make a jit.gl.handle and connect it to the grid shape. Now we can hold down Alt and click on the grid shape to resize it. Another useful Gitmo abstraction is Gitmo circle. Make 2 floating point number boxes. Make a Gitmo circle and give it a value of 30. Connect one of the number boxes to the first inlet. Under it, make a jit.gl multiple object with 2 parameters and an attribute glparams, and we're going to give it 2 parameters, position and scale. Connect the jit.mo.circle to the left inlet of GL multiple. Make a jit matrix 3-plane object floating point 32 and a dimension of 100 and connect that to the right inlet of our GL multiple. Connect the other floating point number to the JIT matrix. Now make a jit.gl.grid shape and connect the output of the GL multiples to the inlet of the GL grid shape. Make the first number of our floating point number box 0.7 and the second number box 0.1. Now you should see a circle of 30 spheres. Let's quickly make a jit.gl.materials and connect that to the grid shape so that we can see the three-dimensional quality of our spheres. You can send messages to the jit.mo func inside the mo circle. Make a message box with speed $1 and connect it to the second inlet of the mo.circle. Attach a floating point number box and change it. You'll see the circle start to spin. Now there's one last thing I'd like to show you. jit.mo function is really great for generating color arrays. Let's add another parameter to our JIT-GL multiple. Change the 2 to 3 and then add a color attribute after the GL params. Now initialize the float inputs again so that you can see the spheres. We're going to take the entire first section we made, the mo.line, the two mo.sin, and also the mo.join, duplicate them, and then connect an outlet from the mo.join to the new color inlet on the GL multiples. You'll now see an evolving color array on our balls, which can be easily manipulated. All of these settings can be changed and manipulated until you find something you're happy with in this patch. As you can see, there are a lot of new possibilities with jit.mo. We hope you'll enjoy this package. That concludes our two-part jit.mo video series. Happy patching!